All right, welcome to the review for the midterm exam. This is going to be the explanations for the questions on the PowerPoint and PDFs. First, let's just go over some of your midterm exam information. The first portion is going to be multiple choice. This will be on the computer this year, but this is basically paper and pencil. There are 26 questions. It's 50% of your grade, and you will be able to use your formula sheet and your Z-score chart the entire time throughout the exam. The second portion is a free response portion. It is paper and pencil. Some of it will be paper and pencil, and some of it will be you typing into Blackboard. It is a total of 5 questions. Worth a total of 82 points, but it will be 50% of your grade for your midterm. Your total exam value is 20% of your final grade. You will get 1 hour and 1.25 hours or 1 hour and 15 minutes for both the multiple choice and the free response exam. It will be timed in the sense that whenever the time is up, the exam will auto submit. So just be aware of that as you're working through this. All right, we're just going to take a minute and go through some review questions. I'm going to go through them with you, and if you have any questions, please feel free to reach out. Since Hill Valley High School eliminated the use of bells between classes, teachers have noticed that more students seem to be arriving to class a few minutes late. One teacher decided to collect data to determine whether the students' and teachers' watches were displaying the correct time. At exactly noon, the teacher asked 9 randomly selected students and 9 randomly selected teachers to record the times on their watches to the nearest half minute. The ordered data showing minutes after 12 as positive and minutes before 12 as negative. So for example, here when we have a -3, that would mean 11:57, and when we have a positive 1.5, that would be 12:01 and 30 seconds, okay? Now, what I have here is the box and whisker plot for both of this data. I would like you to find the 5 summary statistics and the calculations to prove that there are no outliers for the students. What I want you to remember is you can get the box and whisker plot on your graphing calculator. You always want to use the modified box and whisker plot because that will always show you whether or not you have outliers. All right, so in order to do that, what you're going to do is on your graphing calculator, number 1, to put the data in, we're going to put students as list 1 and teachers as list 2. So go to Stat. Okay, we're editing the list. Hit Enter. I've already entered my data in, but all of the students' times are going to be in list 1 and all of the teachers' times are going to be in list 2. Now, we want the 5 summary statistics. So remember, those 5 summary statistics are going to be your quartile 1, your median, your quartile 3, your min, and your max. And your graphing calculator will give you all of that information. So here, once you have the data entered, remember you're going to go to Stat, over to Calculate, and 1var Stats. Now, when you hit Enter, it's automatically going to give you the data for that first list, or list 1. But we have a second list, so we're going to go to Stat, Calculate, 1var Stats again, only this time I'm going to hit second, and then right above the 2 is L2. I'm going to hit that, and that's telling my calculator to get the statistics for list 2. I'm going to hit Enter, and there's all my data. Now, if we just scroll through this, remember X bar is your mean. We don't need the standard deviation. We have right here is our end value. There's 9 data points. Now you have to scroll down in order to get all this information. We have the min, the quartile 1, the median, and the quartile 3, and the max. Remember, if you wanted to graph this, you're going to go to second, y equals, turn that plot 1 on. Now, remember that this right here is going to be your modified box and whisker plot, and hit Enter. Okay, now this is going to graph the first one. Notice how this says L1, so that's pulling your information from list 1, so this is going to graph the students. If you wanted to do a second one, we could go over to plot 2, because this will graph 2 of them at one time. Hit Enter, and we can turn this one on. hit enter, and notice down here, I can get my second one. Okay, so now when I go to graph, notice it's kind of wonky. It's not really the best fit on my graph. Remember, if I go to zoom statistics, which is zoom 9, that is going to give me the best way to view my data. Now, also, if we hit the trace button here, notice how this is going to give you your min, your quartile 1, it shows at the bottom, your median, your quartile 3, and your maximum. And then if you jump down, it'll give you the same information for your other box and whisker plots. All right, so we could get I just showed you how to get the summary statistics. Okay, you'd want to list them, make sure you label them. And then we are going to need those in order to find our outliers. Remember, our outliers are going to be it's either data that's way too high or data that's way too low. So to get your outliers, you're going to take quartile 1 minus 1.5 times the IQR, and quartile 3 times 1.5 plus 1.5 times the IQR. Now remember, in order to get your IQR, it's going to be Q3 minus Q1. So here is our Q3, which is going to be, let me make sure I'm looking at the right one here. Okay, so this is for the students. I'm just picking one for the students. And here is my thing. So Q3 is 1 minus negative 1.75. So my interquartile range is going to be 2.75. And then I'm just going to plug that information into my formula. So my quartile, so here's my upper bound, is quartile 1 plus 1.5 times that IQR. Here's quartile 1. Okay, and this is incorrect. This should say negative 1.75. So to get our lower bound, we're going to take quartile 1 minus 1.5 times the interquartile range. And now here are going to be my upper bound and my lower bound. So anything above 5.125 and anything below negative 5.875 would be outliers. And if we look at our data, there's nothing above 5.125 and nothing below negative 5.875. Therefore, there are no outliers. If you are ever asked what the outliers are, or if there are any, whenever you answer yes or no, you must show the work for the problems. Okay, so please make sure that you're including showing this work right here. So you can either show the formulas and the answers, or you can show this work. So that is really important. So discuss what effect a large outlier might have on the mean versus the median. Remember, an outlier will change the mean. Okay, it will pull it in the direction of the mean. So if you have a big outlier, it's going to make the mean larger. If you have a small outlier, it's going to make the mean smaller. So it pulls the mean in the direction of the outlier. However, the median, it actually has no effect on the median because the median is in the middle of the data. So it's not going to change the position of the median, because if I have a number at the end and I just swap it out for a different number, it's not going to change your median. All right, now let's take a look at the question that now says compare the two distributions. So I want you to take a minute and think about what comparing the two distributions means. That hopefully popped into your head right away and you said that needs to be SOX, okay? So you're going to have to remember this, and it is very, very important that whenever you do this, you use comparative language. So let's take a look at what that looks like. All right, number one, SOX is going to be my shape, outliers, center, and spread. Remember here, we're never stating it's approximately normally distributed. It is either going to be symmetrical, right skewed, or left skewed, and this needs to be in context, okay? So both the distribution of the teacher and the student appear to be symmetrical, with teachers having a slight right skew. So if we take a look at our graphs right here, okay, approximately symmetrical, the whiskers are about the same size, the median is a little bit on the right, but that's okay. Here the median seems to be a little bit more on the left, so which means it's going to kind of look more like this. So that's going to be be maybe a slight right skew. You wouldn't be taken off credit if you said approximately symmetrical for that one. But I also want you to keep in mind, with box and whisker plots, you never state it's approximately normally distributed. We don't know if it's unimodal and bell-shaped, and we need to know that for a normal distribution. So the only thing you can state if it's symmetrical, right skewed, or left skewed. Make sure this is in context. What does in context mean? The distribution of the teachers and the students. You're specifically telling the reader what their distribution they're looking at. If it is not in context, you will get marked wrong. Okay, outliers, there are no outliers for either group. Now, remember with center, you need to compare this using comparative language. Higher, lower, the same, something like that. The median time of the students is higher than the teachers at 0 minutes. Notice that I'm stating the median time of the students, and 1 minute fast for the teachers, okay? And notice I'm stating what it is for the teachers. So the median is higher. Make sure you're including that. And then remember, our spread has a specific explanation here. Remember, we're saying when we are talking about the spread, when you have box and whisker plots, you need to use the IQR. Do not use the range. That is a little bit too broad of a category because most of our data is going to be in the IQR. So the middle 50%, that's our IQR, of the time for students is much more varied. And more varied is going to, that is our comparative language. So you can say more varied, less varied, or is the same. Notice how we have the range of the IQR, and the middle 50% of the teachers is less varied and ranges from -1.5 to 0. So just make sure that you're using comparative language in context and be specific. Anytime you're asked to describe a sampling distributions, this means you are going to have to do SOCs. Now, you haven't quite learned this part yet, so don't worry about that, but you will be doing that in section 6.2 and 6.3. All right, now let's just take a minute and talk about converting some units. So if you were to convert all of the units to seconds, which of the following would change? So this is now all in terms of minutes. So which would change if I converted this all to seconds? Would the minimum change, the quartile one, the median, the Q3, the max, the standard deviation, the mean, or the IQR? Which of those would change? All right, so our minimum is going to change because obviously we're going from a -4.5. Basically, we're multiplying all of these by 60. The quartile one is going to change. But notice our median right here. Our median turns out to be 0. And since that median is 0, that is actually going to not going to change because if I multiply it by 60, that is going to stay the same. Okay, my quartile 3, basically I'm multiplying that by 60, so that's going to change. The max is going to change because I'm multiplying that by 60. The standard deviation and the mean are also going to change all along with the IQR. So in this case, the only thing that's not going to change for the students is the median, and for the teachers, the only thing that's not going to change is your quartile 3. All right, now, based on the box and whisker plots in Part A, I have them listed up here. Which of the two groups, students or teachers, tends to have watch times closer to the true time? Now, how are we going to figure out what the true time is? So remember, the true time here is going to be 12 o'clock. Anything above 12 o'clock, so this is basically like our point of 0. Anything above 12 o'clock is going to be above the true time. Anything below 12 o'clock or 0 is going to be negative. Now, look at our box and whisker plots. Which ones are clustered more closely around the time of 12 o'clock or a time of 0? If you notice here, these watch times here are clustered more closely around this true time of 0. So the teachers tend to have a watch time that are closer to the true time, even though they tended to be a little bit slow. They're less variable, which means they're closer to that time. Okay, we can also take a look at the IQRs right here. The IQRs of the teachers had one of 1.5 minutes, which was not that large. However, the students' IQR had a time of 2.75 minutes. So therefore, they were further distance from the actual true time. So whenever you're answering questions like this, make sure that you actually have a conclusion. The teachers tend to have watch times closer to the true time. Make sure you have a reason because it says explain, they're less variable, and then use data to compare your answers.